From part 2, we already know that 2x minus 3 is a factor of px. So let's try to find the quadratic factor of px by dividing px by 2x minus 3. So let's do a long division. 2x minus 3. And here we will have a 2x cubed plus 5x squared. There's no x here, so I'll write it as 0x minus 18. So here we will have an x squared. So x squared multiplied by this, it will give me a 2x cubed minus 3x squared. Then this minus this, it will be 8x squared, 0x, I will bring it down, so I have this. So here it will be plus 4x, this will be 8x squared. Then this times this minus 12x. So we will have this minus this, it is 12x, bringing this down, minus 18. Here we will do a plus 6, so I have a 2x minus 18. We are expecting 0 as the remainder because we are dividing this by its own factor. And this tells me that px is equal to 0 can also be rewritten as the multiplication of the two factors, which is this, and x squared plus 4x plus 6 is equal to 0. Which means that 2x minus 3 must be equal to 0, or x is equal to 3 over 2. This was one possible case. The other possible case is when x squared plus 4x plus 6 is equal to 0. And for this quadratic equation over here, if we were to check the discriminant is going to be b squared minus 4ac, so 4 squared minus 416. This is getting us a negative 8. Negative 8 is less than 0. So for quadratic equation, when the discriminant is negative, that means this quadratic equation, it has no real roots. Which means that when px is equal to 0, the only root that we have is x is equal to 3 over 2. And this will help us to answer the question because we have hence shown that px is equal to 0 has only one real root.